The tire of Malcolm's motorcycle has a radius of 13 inches. There's a tack in the tire, and the bike is moving at a constant speed, so the tire rotates 5 times every second. So I'm going to break down what's been given to us so far. We have a radius of 13. So from the center to the outside of the tire would be 13 inches. The tire rotates 5 times every second would be the frequency. The definition of frequency is how many times the periodic function cycles through the pattern in 1 unit of time. So 5 times per second would be the frequency. Remember, if you're given the frequency or the period, you can use one to find the other. The frequency and the period are reciprocals of each other. So the period, instead of being 5/1, would be 1/5. So frequency is 5, period is 1/5. We're going to write the function, we're going to call it h of t, which is going to represent the height of the tack from the ground over time, which is in seconds. This part right here, assume maximum displacement, means that we are going to start at the highest point on the graph. So that means when we start timing at time equals 0, the tack is starting at the highest point from the ground that it possibly could. Now, maximum displacement indicates that we are going to use a cosine function here. Now, I'm going to draw a picture of this so you can get a sense of what this is going to look like. I've drawn an x-axis and a y-axis. I'm going to call the x-axis time, which is in seconds, and the y-axis is height. Now, we've got this tire with a radius of 13 inches. So if the tack is starting at the highest possible point on the tire, it's going to be up here somewhere, right? Now with a radius of 13, that's only halfway from the ground to the tack. So that means this tack is way up here at 26 inches. So the center of the tire would be 13 inches. So again, we're pretending that this x-axis that I've drawn is the ground. If the tire has a radius of 13 inches, the tack at the very top of the tire would be 26 inches above the ground. It's twice the radius. Now, as this tire rotates, the tack's height is going to reach its maximum height of 26, or it's going to reach its minimum height of 0, which would be hitting the ground. Or it can be any height in between 0 and 26. But this tire is never going to leave the ground, and he's going to be going at a constant speed, so the tack's height is going to follow a periodic function. Now, if I actually draw this graph, again, the height would be 26. Halfway above the ground, the tack would be at 13 inches, or we have the ground down here at 0. We're assuming maximum displacement, which remember means that we're going to have a cosine function, and that function is going to start up here at 26. That's the maximum height. The lowest the tack can get is 0, and that's going to happen halfway between a period. And then eventually we'll get back to the top of that tire. Now, we said that the period was 1/5. So in 1/5 of a second, the tack starts at its highest point. It travels around the tire until it hits the ground, and then its height increases as the tire continues to rotate until we get to the top of the tire again. And then it does that forever, as long as the tire is still going at that same speed. So the equation of this function, remember, is cosine. A would be the amplitude. Remember, amplitude is the height of the wave. In this case, it's not 26. Remember, it's from the middle to the top. This graph is cut in half at 13. So the distance from the middle to the top or the middle to the bottom would be 13, which means the amplitude is 13. We need to find B. Remember, B is not 1/5. B helps you find 1/5, which was the period. We know the formula for period is 2 pi over b. In this case, we know the period is 1/5. So 2 pi over b must equal 1/5. If we cross multiply, we find that b is equal to 10 pi. So finishing this out, amplitude is 13, b is 10 pi. Now, the problem is the equation that I have written as it is has not shifted up in order to account for the ground being the x-axis. Remember, the center of this periodic function, the line that cuts it in half, is going through 13. So we have to shift the entire cosine function up 13 in order to avoid having any negative height.